Today I'm going to solve LeetCode 128, longest consecutive sequence. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O of n time. Consecutive means that the next element is greater than the previous element by 1. So this is not a consecutive sequence because 3 is greater than 1 by 2. If I added 2 between here, then it does become a consecutive sequence. So for example here, the longest consecutive sequence is 1, 2, 3, 4. And here, the longest consecutive sequence, it doesn't have to start at 1, by the way. It could be 3, 4, 5, and that's a valid consecutive sequence. It would be, oh, there's 9 here, so it would be like 2, 3, 4, 5, 6, 7, 8, I think. Or 0, 1, 2, 3, 4, 5, 6, yeah. So anyway, that's the longest consecutive sequence. Must write an algorithm that runs in O in time, so that means we can't sort it, because sorting on average takes O of n log n time. So we can't sort it. So to detect if there's a consecutive sequence we should check, we should start at the smallest at the beginning of this consecutive sequence. So in this case it would be 1 here, because if we started at 3, we have to go backwards, like 3, 2, 1. We also have to look forwards, look at 4, and that can get tricky. So it's best to kind of start from the smallest element and build up from there. But how can we tell it's the smallest element? Well, if it's the smallest element if n minus 1 doesn't exist. So if we're looking at 100, if 99, the number 99 doesn't exist, then possibly starting from 100, it could be 101, 102. We know that there isn't, but the algorithm thinks there could be. The algorithm doesn't. We need to tell the algorithm that. So there might be a case where there might be 101, 102. And so from 100, since 99 doesn't exist, so from 100 we need to check if there's a 101. If there isn't, then we just found the length of the longest consecutive sequence here would just be 1 of 100. Similarly for 4 here, we see that 3 does exist. So we're just going to ignore 4 for now because it's kind of hard to count backwards and possibly count forwards if a 5 does exist. For 200, 199 doesn't exist, so let's start counting the longest consecutive sequence starting from 200. So does 201 exist? No, it doesn't. So we still have our length of the longest to still be 1. Now we look at 1. 0 doesn't exist, okay. And so we start looking for consecutive elements starting from 1. Do we have 2? Actually, we do have 2. Okay, let's build from there. Do we have 3? We do. Great. And then do we have 4? Yeah, we do. So the longest consecutive sequence running total right now is 4. Do we have a 5? No. So right now the running total is 4, and we update our longest to be 4. And similarly for 3, we have a n minus 1 here, 2, so we're just going to skip that. And for 2, we have n minus 1 of 1 here, so we skip that. So using this, we have the longest of 4. This algorithm runs in O of n time, as the question states. And how are we going to find the next consecutive element? We're going to store these numbers in a set. So the set is O1 lookup. It's like a dictionary except it doesn't store values, only stores keys. And we're going to store all these numbers in set, so like 100, 4, 200, 1, 3, 2, and it's O1 lookup. So that means if we're at 1 and want to find 2, it's O1 lookup 2. It's a constant time lookup to find 2. And that's how we're going to go about it. Okay, now to code this up. So first I want to initialize our longest variable to be 0. This is what we're going to return. And then we're going to have elements set equal to a set. And for I in nums, if I not in element set, we're just doing this because this question doesn't specifically say there won't be any duplicates, and we don't care if there are duplicates or not. We just want the longest consecutive total, so we're just going to count each element just once. It doesn't matter. So if like this is, if we have 100 here and this 200 is also 100, we don't care there are 200s. We just care about just the one value, 100, in our consecutive elements. What we're going to do here is add on. Okay. And now we're going to increment to this, or do this array again. If I minus 1 not in element set, we're going to initialize running max equal to 1. 1 because since I minus 1 is not in its element set, we're just looking at I, and the total number of elements in the set would be just 1 itself, basically. Okay, so if I minus 1 not an element, that's set, where value equals I, and while for value plus 1 in elements set, I'm just going to increment this guy and this guy here. Increment it. And after all that, if we're done, once we're done, we're just gonna initialize longest to be the max between itself and running max. And at the end here, we're gonna return longest. Okay. So let's run through this. So we added all our elements here to this set. So we have 100, 4, 200, 1, 3, 2. Longest is 0 right now. And for each element in nums, if one lower than it does not exist in our set here, we set run max to 1, and the current value that we're gonna change up to I, and while one above it exists in element set, we're going to set the current value to 1 above it and increment running max. So if we have 100 here, running max will be, this longest will be 0, running max will be 1, current value will be 100, and while current value plus 1 in element set, so while these should probably be net. So if 101 in elements of set, we increment current value, and random access plus equals 1. Now it turns out 101 is not in the set, so we don't enter this at all. And the longest should be the maximum between max and longest, which is right now 1. With 4, it turns out I minus 1. 4 minus 1 of 3 is in element set, so we skip it. 200, same deal as 100, it's just going to be running max of 1. Now 1, this is where it gets interesting. So if 1 minus 1 not an element set, so there's no 0, so this is probably the smallest value in our longest consecutive elements. We set this to 1, current value to I, and if 2 an element set, we set current value to 2 and running max to plus equals 1. Okay, and then this should actually be a while. Sorry, we need to keep a loop into this. It's not just a one-off instance. And so we have 2, and then current value is 2, and while 3 is element.set, we increment current value to 4, and this guy would be equal to, so it would be 1, 2, 3, so it would be 3 at that moment. And then while 4 is in, the current value is equal to 4, running max is 4, and the longest is 4. Let's try running it. Okay, that works. Let me try submitting. Okay, great. That's it. Thanks for watching.